నమస్తే మై డియర్ స్టూడెంట్స్, నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్. డైరెక్టర్ జేసీ సార్ ఆధ్వర్యంలో శశికాంత్ వాల్మీకి సార్ పర్యవేక్షణలు నిర్వహిస్తున్న సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఈసెట్ 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో, ఎవరైతే క్వశ్చన్స్కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ని ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేస్తుంది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారనే ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్స్ మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
Now here this is question number 121. A square wave of plus or minus 20 volts is given to this clamper circuit. This is clamper circuit, this is capacitor, this is diode, this is a reference voltage is given. What is the minimum and maximum values of the output voltage? First of all, the given circuit, see here, this is the clamper circuit is given here. This is the clamper circuit. If it is figure is like this, this is positive clamper. This is what? Positive clamper. So the output voltage completely shifted to 0 volts to 2 Vm volts. 0 volts to 2 Vm volts. Here what is Vm means 20 volts. What is Vm? 20 volts, remember. So if there is no reference voltage, then what is the output voltage means 0 volts to 40 volts. If there is no reference voltage, the output voltage waveform is 0 volts to 40 volts. But this is a positive clamper with a negative reference. This is minus plus 10 volts. So, negative clamper with a negative reference voltage. Negative reference voltage. What is the reference voltage here? 10 volts. So, we are adding 0 minus 10 volts to 40 minus 10 volts. So, 0 minus 10 means what? Minus 10 volts to 40 minus 10 means what? 30 volts. So, what is the correct answer here? Minus 10 volts to 30 volts. Minus 10 volts to 30 volts. Hence, it is a positive clamper with a negative reference voltage. The output voltage is minus 10 volts to 30 volts.
In a series RLC circuit at low frequency, the circuit is series RLC circuit. If you see, right, what will be the total impedance? R plus J into XL minus XC. But at low frequency means omega is low. Omega is low means what will happen? XL is proportional to omega. When omega is low value, XL is also low value. What about XC is proportional to 1 by omega? If low frequency means XC is more. So here if you see XC is greater than what? XL, then Z becomes what? R minus JX we get, where X is equal to XL minus XC. So definitely R minus Jx means the behavior is what? A capacitive in nature, right or not? Because capacitive reactance is dominant at low frequency, so definitely overall circuit is behaving like capacitive. So that will be our right answer here. Next one, if you see, find the current flowing in the resistor R4. Here R4 is present. If you observe here, what we will get? First of all, to find the current, I am going with nodal method. Here I am assuming 0 volts and this node voltage is V. Assume all the currents are away from this. So if you apply the what? KCL at that node, so what we get? V minus 12 by its branch resistance 4. Next V minus 0 by its resistance is what? 8. Next V minus 0 by, both branches are connected in series, 4 by 3 plus 6. So if you simplify here, if you take voltage common, what we get? 1 by 4 plus 1 by 8 plus, if you take LCM, 3 6 by 18 plus 4 22, and 3 comes to 3V by 22 we get, which is equal to 12 by 4. Now if you simplify here further, so V is equal to how much we get if you simplify this, right? If you solve that, voltage V is equal to 5.86 volts we get, right? And once if I know the voltage, what will be the current through R4? That voltage 5.86 by 4 by 3 plus 6. 4 by 3 means 1.33. So 5.86 by 1.33 plus 6 means 7.33. If you simplify, the current will be, right? So 0.79 something means 0.8 amperes we get. So 0.8 amperes is available here. That will be the what? Our correct answer. Simple nodal method. Or otherwise I can do even other fashion. What is that? Both are connected in series and equivalent is in parallel and equivalent is in series. So 12 by that equivalent will give current. After having the current, again follow with current division, you will get the current like that also. You can follow with any one of the method, you will get same answer. Next question, if you see, calculate the equivalent inductance of the following circuit. Okay, if you observe from here, what will be the L equivalent, how it is connected? 2 and 1 both are connected in series. Equivalent is in parallel with what? 3. Again equivalent is in series with what? 4. Again equivalent is in what? Parallel with 5. So if you simplify here, 2 and 1 series means equivalent is 3. 3 is in parallel with 3 plus 4 equivalent is in parallel with what? 5. So 3 is in parallel with 3 means 1.5 plus 4. Plus 4 means series is in parallel with 5. So 5.5 is in parallel with what? 5. So what will be the equivalent inductance? 5 into 5.5 by 5 plus 5.5. Got the point? And if you simplify this, so here 27.5 by 10.5, and if you simplify here 2.619 Henries is the equivalent inductance. Simple, okay, relations are similar to our resistance, so there won't be any difference in the calculation part. Okay, next one, if you see here, what is the next question we have? An ideal constant voltage source has, ideal constant voltage source means like this. This will be the what thing. So this is ideal. Practical, if you see, practical means will be having resistance Rs. This is what practical, and this is what ideal. So when you compare here, what is Rs here? 0 ohm. So 0 internal resistance is the what right option for this. Okay. Next one, if you see, in the following circuit, what is the voltage across this 2 kilo ohm? That is the what question. First of all, it is a Wheatstone bridge circuit, and we have to check the what balanced condition here. So whether it is balanced or not, we need to deal with that. When it is balanced, you no need to count this. Check that balanced case. 1K is opposite to 6K, which is equal to 2K is opposite to 3K. Yes, we get what balanced condition. Yes, balanced one. Bridge is balanced, so you no need to count this 10 kilo ohm resistor. Then how the circuit seems to be? If you are avoiding that branch, then the network becomes like this. Okay, here is our what 12 volts, and this is 1 kilo ohm, this is 2 kilo ohm, this is 3 kilo ohm, and this is 6 kilo ohm. So if I consider this is the reference voltage 0, then what will be the voltage here? Node voltage becomes what? Same 12 volts only. So 12 volts connected across these two parallel branches, but this 12 volts will be divided for this. We want voltage across 2 kilo ohms. By voltage division rule, by voltage division rule. So voltage across 2 kilo ohm is equal to total voltage is how much? 12, is dividing based on the corresponding impedance 2 kilo ohm by 2K plus 1K. So if we solve this, 12 into 2 by 2 plus 1 3, 3 4s are 4 2s are 8 volts. Simple one, okay, but you have to recognize that bridge circuit is balanced. Okay, so we got this result, right?
Now this is question number 127, GNR diode question as a voltage regulator. The 6 volts GNR diode shown in figure has 0 GNR resistance and a knee current of 5 milliampere. The minimum value of RL so that the voltage across it does not fall below 6 volts. So first of all, I am calculating this current I. I am calculating this current I. So what is that current? If you apply KVL, I equals to, I am writing V minus Vz by R. V minus Vz by R. What is the applied voltage here? 10 volts minus what is the GNR voltage? 6 volts divided by 50. So 10 minus 6, 4 volts by 50. 4 by 50. That means I am doing here 5 by 4, 0, 0.8. So 0.8, that means 0.08 amperes. So 0.08 amperes I am writing as 80 milliamperes. What is the current here? 80 milliamperes. Now this current after this node, it is dividing into two currents IZ and IL. IZ and IL. Here knee current is mentioned, that is Zener current. What is Zener current is given as 5 milliampere. So total current is 80 milliampere, Zener current is 5 milliampere. Then what is load current? 80 minus 5, that equal to 75 milliamperes load current. What is the value? 75 milliampere. Now is asking load resistance RL. RL is equals to, I am writing formula V0 by IL. Here V0 means what? VZ, Zener voltage, divided by IL. What is VZ? 6 volts divided by 75 milliamperes. So I am writing this milli here 1000. So 25 3 ja 75, 25 4 ja 100, 3 1 ja 3, 3 2 ja 6, 2 into 40. 2 into 40 means how much? 80. Answer is 80 ohms. What is the answer here? 80 ohms. So that option 2 is correct. Option 2 is what? 80 ohms. Next question 128. In an RC phase shift oscillator using BJT, oscillations happen at the frequency where the feedback network shifts the phase of the amplifier output. So according to Barkhasan criteria, to obtain oscillation or to sustain oscillation, there are two conditions. One condition is what? Closed loop gain must be unity. And second condition is the total phase shift around the closed loop must be 0 degrees or 360 degrees. So here in RC phase shift oscillator, we are using one CE amplifier and one feedback network. The purpose of CE amplifier is to provide 180 degrees phase shift. So to satisfy the condition, the remaining 180 degrees phase shift will be obtained by using feedback network. Here the question is asking same thing. The feedback network gives how much phase shift? Answer is 180 degrees phase shift. The remaining 180 degrees phase shift obtained by using a common emitter amplifier. Here common emitter amplifier gives 180 degrees phase shift and the feedback network gives 180 degrees phase shift. Here our question is the feedback network gives how much phase shift? Answer is 180 degrees phase shift.
Now let us discuss the solutions of the subject communication from Ecet paper. The first question is like this. The condition for achieving distortionless demodulation of amplitude modulated signal using an envelope detector is. First point what you have to remember is this envelope detector is used for demodulation of amplitude modulated signals, and this envelope detector will work if the modulation index mu is less than or equal to 1, and if the modulation index mu is greater than 1, this envelope detector will not work. Means envelope detector will work for under modulated signals and critically modulated signals, but for over modulated signals envelope detector will not work. So among the options he is asking for which signals envelope detector will work. Now here you can select option 2 as the answer because modulation index less than 1 is given, right. Now let us look at the next question. Yeah, this is the next question. This is from digital communication, and in this question he said in a PCM system with uniform quantization, increasing the number of bits from 8 to 9 will reduce the quantization noise power by a factor of. First point you have to remember is that if the number of bits are increased, definitely there is a reduction in quantization noise power. And how to remember this one? You can remember this expression. Step size delta is proportional to 1 by 2 power n. Step size is nothing but VH minus VL by L, no? L is nothing but 2 power n. So I can write step size is proportional to 1 by 2 power n, and quantization noise power, if I take quantization noise power in uniform quantization is what? Delta square by 12, delta square by 12. So delta square means proportional to 1 by 4 power n. Delta is proportional to 1 by 2 power n means quantization noise power is proportional to 1 by 4 power n. Now here n is increased by n is increased by 1 bit, means here nq is proportional to 1 by 4. nq is proportional to 1 by 4 means quantization noise power will be reduced by 4. Quantization noise power is reduced by a factor of 4. You can take option 3 as the answer. Right, and you can extend this if you want. So step size, and after this is step size now, and maximum quantization error is also proportional to 1 by 2 power n, because maximum quantization error is half of the step size now, and signal to quantization noise ratio, it increases, and it will be proportional to 4 power n, or in dB also you can write 6n dB. If you can remember these relations, yes, analysis becomes very easy. Let us look at the next question. Yeah. Which of the following is a type of multiplexing techniques in which signals are transmitted in the form of data samples? So if you observe the first option, PPM, it is not a, see, data samples means what? It is related to digital. So PPM, PWM are analog modulation schemes. So this will not come. PPM is not the answer, PWM is not the answer, and is talking about the multiplexing technique. PCM is not a multiplexing technique, pulse code modulation, whereas you can select option D, time division multiplexing, as the answer. Okay, now let us look at the next question. Yes, a signal of maximum frequency 10 kilohertz is sampled at Nyquist rate. The time interval between the successive samples is, always remember, the maximum duration between the successive samples when you are going for sampling is given by 1 by 2 f max. 1 by 2 f max, or what is this equal to? 1 by 2 times of f max. What is the maximum frequency? 10 kilohertz. 10 kilohertz, or this is 1 by 20 into 10 power 3, or this is 0.5 into 10 power minus 4, or this is 50 microseconds. TS max is what? 50 microseconds. Now we have to search for this answer. So where is the answer? Yes, option 1, 50 microseconds is the answer. Hope you understood this problem. Let us look at the next question.
Now this is question number 133. Given figure shows a silicon transistor connected as a common emitter amplifier. Then the quiescent collector voltage of this circuit is asking collector voltage, VC is asking. So from that circuit, VC equal to simply VCC minus IC into RC. This is the formula. VC equal to VCC minus IC into RC. Here VCC equal to 20 volts, RC equal to how much? 10K. RC equal to 10K. So what is VC? To find IC in common emitter, we are using a formula IC equal to beta IB. IC equal to what? Beta IB. Beta value is given as 100. Now we want IB according to voltage divider biasing. IB equal to V Thevenin's minus VBE divided by R Thevenin's plus 1 plus beta into RE. This is formula. 1 plus beta into RE. V Thevenin's minus VBE by R Thevenin plus 1 plus beta into RE. Again V Thevenin's is equals to what? V Thevenin is equals to VCC into R2 by R1 plus R2, and R Thevenin's is equals to RB1 into RB2, RB1 into RB2 divided by RB1 plus RB2, RB1 plus RB2. So VCC is given as 20, R2 is 5 kilo ohms, divided by R1 plus R2, 10 plus 5, 15, 5 1 ja, 5 3 ja. So, what is Vthevenians here? 20 by 3 volts. Similarly, RThevenins equals to, I am writing RB1, that is 10K, RB2 5K divided by 10 plus 5, 15, 5 1 ja 5, 5 3 ja 15, that equal to 10 by 3 kilo ohms. So, this is Vthevenins value, this is RThevenins value. If you substitute this Vthevenins value here, I am substituting all values here, IB equals to Vthevenins 20 by 3 minus VBE, he mentioned silicon, so I am writing 0.7 volts divided by RThevenins 10 by 3 plus 1 plus beta 101 into RE 10 kilo ohms. So, if you simplify, you will get some value, and from that you multiply with IC, beta value you will get IC. If you substitute, you will get approximately 14 point something. So, correct answer is here, 14 volts is the answer.
Yes. Identify the mathematical expression for amplitude modulated wave. Amplitude modulation is defined as the process in which amplitude of the carrier is varied in accordance with the message signal. Now, if you take the first option, here AC is the amplitude, here there is no change in the amplitude of the carrier. So, option 1 cannot be the answer. Option 2, if you observe, so with amplitude modulation there must be a change in the amplitude of the carrier. Option 2, there is no change in the amplitude. Option 4, if you observe, there is no change in the amplitude. Here if you observe option 3, there is a change in the amplitude. So, option 3 represents an AM signal. Option 3 represents AM signal. Let us look at the next question. The data rate of QPSK, that is quadrature phase shift keying, is dash as that of BPSK for the same symbol rate. See, in BPSK, what happens, we are going to have, see in BPSK, after analog to digital conversion, that for each digital bit we are going to generate one phase. For each bit we are going to generate one phase. Whereas in QPSK what will happen? The bits are lumped, 2 bits are lumped so that it forms a symbol. For that phase is generated. Phase is generated. Right here in BPSK, see here for each individual bit one phase is generated, whereas in QPSK 2 bits are lumped together so that they form a symbol, and for that symbol a phase is generated. Suppose if you are going for 8 PSK, 3 bits are lumped together so that it forms a symbol, for that a phase is generated. So here obviously here QPSK, what I am saying, 2 bits are lumped together so that it forms a symbol and phase is generated, and here for single bit phase is generated, means here from that saying only we can say the data rate of QPSK is what? Twice that of BPSK, twice, because 2 bits are lumped together. Suppose if I ask you the data rate of 8 PSK is dash that of BPSK, means what? 3 times, because 3 bits are lumped together. Lumped means combined, and for that a phase is generated. Okay. So, here you can say option 2 is the correct answer. Option 2 is the answer, right? Now, let us look at the next question.
Now, question number 136. What is the value of capacitor of the Wien bridge oscillator operating at resonant frequency of 10 kHz with a resistance of 100 kilo ohms? Here in Wien bridge oscillator, what is the frequency of oscillation formula? F0 is equals to 1 by 2 pi RC. F0 equal to 1 by 2 pi RC, frequency units are hertz. Here frequency value is given as 10 kilohertz. What is the frequency value is given as 10 kilohertz? 10 into 10 power 3, that is frequency, is equals to 1 by 2 into, I am writing pi value 3.14 into R value is given as 100 kilo ohms, 100 into 10 power 3 into capacitor. We want to calculate capacitance value. From this I am writing C equal to 1 by 2 into 3.14, that is 6.28 into 10 power 3 to 5, 5 plus 1, 6 plus 3, 9. 1 by 6.28 into 10 power minus 9. If you simplify, you will get 159, that is 0.159, 159 pico, that means into 10 power minus 12 farads. So, what is the answer here? 159 picofarads. Option 2 is the correct answer.
Yeah. A super heterodyne AM broadcast receiver has an intermediate frequency, IF means intermediate frequency of 455 kHz. If it is tuned to a frequency of 700 kHz, the image frequency is. The expression for image frequency can be given as FSI, that is image frequency, is equal to Fs plus 2IF. Fs plus 2IF. So, here what is the Fs value? Fs value is station frequency, which is nothing but 700 kHz plus twice of intermediate frequency. Intermediate frequency is 455 kHz. 455 kHz. So, if you simplify this one, you will get 1610 kHz. This must be your image frequency. So, you can say let option 1 as the answer. Option 1 is the correct answer. Next question. Yeah. What is the Hamming distance between the codes? He gave the two codes. Hamming distance means the locations in which the two codes are different. The number of locations in which the given codes are different is nothing but Hamming distance. So, what are the codes he gave? 1, 1, 0, 0, 1, 0, 1, 1. This is one code, and the second one is 1 followed by 4 zeros, 1, 1, 1. And what did I say? If you want Hamming distance, you must find out the number of locations in which these codes are different. Now, if you observe, same, same, different, different, same, same, different. So, how many locations they are differing? 3, means Hamming distance is 3. So, from the options you can select option 2 as the answer. Option 2 as the answer. Let us look at the next question. Yeah. Consider a message signal m of t which is given by 3 cos 100 pi t plus 2 cos 200 pi t. If the signal undergoes a frequency modulation with a frequency sensitivity constant 20 Hz per volt, the bandwidth of the modulated signal is. How to find out this one? Here, first of all, let us write the message signal, given message signal. M of t is 3 cos, it is a multi-tone signal, no? Multi-tone means if the message signal consists of more than one frequency, the signal is said to be multi-tone signal. This is a message signal. And what is the other information he gave? Frequency sensitivity constant he gave 20 Hz per volt. 20 Hz per volt he gave. Right? So, he is asking us to calculate the bandwidth. So, bandwidth expression is given by twice of delta f plus fm, where fm you have to take the maximum frequency. Maximum frequency means what? Here this is the maximum frequency, or fm is equal to maximum frequency. Here frequency is maximum now, 200 pi divided by 2 pi, which will come out to be 100. Fm value I got. Now I must get the value of delta f. Delta f, that is the frequency deviation, is given by kf into m of t max. Kf into m of t max. Now m of t is this one. What is the maximum value of m of t? So two cos terms are there, no? So maximum value occurs when this t is 0 or any multiple of 2 pi. Multiple of 2 pi. So here what happens if I substitute t is equal to 0? T is equal to 0 means this value is 3, this value is 2, right? This value is 3, this value will be 2, so that delta f is equal to 20, m of t max will be 5, which is nothing but 100. M of t max is 5. Now bandwidth is equal to twice of delta f is 100 plus fm 100. So this is nothing but 400 hertz. 400 hertz must be your answer. So among the options you can select option 3 as the correct answer. Hope you understood this one. Let us look at the next question. Yeah, which of the following is used for the generation of SSB modulation? SSB modulation, if you observe or if you remember the expression for SSB modulation, it is given by half AC m of t cos 2 pi f ct minus or plus half AC m cap of t multiplied with sin 2 pi f ct. This is the expression for single sideband modulation, where we have to use minus for upper sideband and plus for lower sideband. Here if you observe, m of t is a message signal, m of t is a message signal, and m cap of t is the Hilbert transform. Hilbert transform of m of t, which is used to give 90 degrees phase shift. 90 degrees phase shift. So here, which of the following is used for the generation of SSB modulation? Means PLL, no, it cannot be used. Balanced modulator, no. Square law modulator, no. So Hilbert transform. Hilbert transform. Basically, whenever you are going for generation of SSB using Hilbert transform, it is known as wideband 90 degrees phase shift. Generally, it is called Hilbert transform. In SSB is called wideband 90 degrees phase shift. This block will be having wideband 90 degrees phase shift. So option 2 becomes the correct answer.